Hello there, I'm Thomas Hatsios, a British American pilot flying the Boeing 777-300ER into tonight's flight from Zurich International Airport. We're going to be flying Zurich, Switzerland, Germany, and then coming back to the Zurich International Airport, runway 1449, Lszh localizer. Landing so right now in the cockpit for the pre-takeoff preparation of the PMGC of the Boeing 777-300ERX of the PMGC and Flight Simulator X. So I'm gonna start showing you the cockpit instruments, the displays and the functions of the Boeing 777-300 ER aircraft. I'm gonna start with the primary flight display. The primary flight display that displays the airspeed indicated. Let's see here. So you can see the airspeed indicated. The airspeed tape, the airspeed selected from the autopilot of the flight director system panel, the ground speed, the magnetic heading and track, the radio altitude above the ground level, the barometric pressure of the outside atmosphere, the barometric pressure altitude, and the barometric pressure altitude, and also the altitude selected from the autopilot and flight director system panel. We have also the vertical speed indicator that displays the rate of climb and descent of the aircraft, how steep the aircraft climbs or descend in terms of trigonometric angle. It decreases also the flight director crossbars and the Lszh localizer crossbars for manual guidance of the aircraft, and also we have the autopilot crossbars for automatic guidance of the aircraft. We have the primary flight display also, the altitude indicator, the pitch ladder in decrease, and the bang angle in decrease. We have also the magnetic heading and track, the magnetic north pole and the true north pole, and the magnetic variation depending on where we are in the world. We also have the flight mode associated with the autopilot and the autothrottle later on vertical navigation modes. So I'm gonna show you then the navigation display. You can see here the navigation display that displays so we have the navigation display. The navigation display that displays the airports, the waypoints, the GPS position of the aircraft. We have again the magnetic north pole and true north pole, and the magnetic variation depending on where we are in the world. We have the distance in rings, the nautical miles. You can see the terrain map around the aircraft. You can see also other airports and other aircraft flying around aircraft, the distance they are located, the altitude difference, the direction, and also their airspeed. So we have the calculations from the computer and the TCAS system, the traffic collision and alert system that uses the transponders, the ADSB and ADC transmitter receivers, displays other aircraft in the navigation display like a pulsar radar. Okay, we have the terrain reflections from the weather radar. Also we have the flight management computer. We're talking about now. We have the ground speed and the airspeed, the wind direction, and the vector of the wind. We have also the next waypoint. We're going to be overflying the GPS position, and the RNP and the INP, the required navigation performance and the acquired navigation performance. We also have the flight management computer. We're going to create a flight plan using the departure airport. We're going to select the runway we're going to use for departure. We're going to input the seats, the starter instrument departures, the aircraft data like takeoff weight, the empty weight plus the fuel, the trip fuel plus the taxi fuel and the reserve fuel, and also the cargo and the passengers on board. So we have the takeoff weight, and we also have the runway data. We have the runway length and other conditions like the barometric pressure, the air density, the temperature of the air, and the wind direction and airspeed, and also if the runway is dry, wet or ice. So we're gonna have the calculations about the takeoff speed. So we're gonna use the flaps in the wings that increase the lift, and also the horizontal trim stabilizer is gonna be calculated for takeoff. The horizontal trim stabilizer position in terms of mean aerodynamic chord of the aircraft and the center of gravity of the aircraft calculations. So we're gonna use the departure runway, the seats, the standard instrument departures, intermediate waypoints and fixes, and the destination airport and runway. The stars, the standard terminal arrivals, fixes and waypoints. So we're gonna have a vertical and lateral profile for the aircraft to fly either manually or automatically using the autopilot and flight director system panel with the auto throttle. Also, I'm gonna show you now. So we have, you can see here, you can see the primary flight display, the navigation display, the autopilot and the flight director system panel, the upper and the lower ACAS, and the thrust levers. So, so the autopilot contains the autopilot engage and disengage switch, the auto throttle left and auto throttle right, engage and disengage switch, the LNAV and the VNAV, the lateral navigation, the vertical navigation, engage and disengage, which is interconnected with the flight management computer flight plan we're going to create. Also, we have the airspeed select node. We can select an airspeed in nautical miles per hour or Mach speed. So the nautical miles per hour are knots per hour. So we have also the modes for the airspeed select node that commands the auto throttle and the thrust levers position, the engine power rate produced by the engines that we have installed in this aircraft. The Boeing 777-300ER has General Electric 90 G90 right now for this simulation. So we have a lot of thrust produced. We have a turbofan turbojet engine in either left and right wing. So we have symmetrical thrust and redundancy. So the airspeed select node, we select the airspeed, and this commands the auto throttle, which commands the FADECs. The FADECs are installed in either left and right engine. They are the full authority digital electronic control computers that control and monitor the engine functions, and also the engine electronic control computers, the EC, in the overhead panel. So the auto throttle, the flight director, the autopilot, they all work together, and we have the airspeed command mode, depending on what kind of flight phase we are and what we're trying to do. So we can select either fixed thrust mode or variable thrust mode for automatic thrust. So we have the flight level change, the climb continues, and the auto throttle with the speed mode. So like if we are in the takeoff, go around, or climb mode, we have a fixed thrust, maximum continuous fixed thrust for instance, and the airspeed is being adjusted while the aircraft climbs by varying the rate of climb or descent of the aircraft using the horizontal trim stabilizer and the horizontal tail elevator commands from the autopilot and flight director system panel. Also, when we descend, we have a fixed thrust, idle thrust, and we have the variable thrust modes in the cruise when the aircraft is cruising, or in approach and landing. We have variable thrust while the aircraft altitude is being held constant while in cruise flight, for instance. So we have also the LNAV and the VNAV. We have the bank angle limiter. We have it right now in the auto. We can select how many degrees we want the autopilot command the aircraft to bank roll in cruise, like 5, 10 or 30 degrees, 35. So we have also the heading select node and the heading hold switch. We have the vertical rate of climb or descent of the aircraft in tens, hundreds and thousands of feet per minute. That is being displayed in the vertical speed indicator, and also we have the slider for adjusting how steep we want the aircraft to climb or descend in terms of trigonometric angle in degrees, the flight path angle, the FPA, that is being displayed in the pitch ladder in the primary flight display altitude indicator or the vertical speed indicator if we use the VS mode. We have also the altitude select knob and the altitude hold switch, and we have the roll localizer switch and the approach for auto run. So I'm gonna show you after that. I'm gonna show you the thrust levers I talked to you about already. We have the General Electric 90 G90 turbo fan turbocharged engines installed in our aircraft. So this is a jet aircraft. So we have the thrust levers also for manual or automatic guidance of the thrust commanded. We can use the airspeed knob. As I told you, we can move the thrust levers manually. So we have also, I'm going to talk to you about the flight theory of the aircraft, about the Newton's first, second, and third law of kinematics of motion, about the Bernoulli theory of fluids, about aeronautical and aerospace engineering. Then I'm going to show you how to calculate the takeoff speeds, the flight management computer, set up a flight plan, a complete flight plan. Also, I'm going to make an engine start demonstration. I'm going to shut down the engines and restart them. Also, I'm going to show you the overhead panel, the left and the right IDC, the great drive generators that produce alternate current using the engine horizontal engine shaft. I'm going to show you so that we have 120 to 200 volts, 400 hertz alternating current. Free phase about 120,000 kilovolts or 120,000 watts either left and right IDC, 25,000 kilovolts or watts either backup generator left and right. We have also the APU, the auxiliary power unit we need to start the engines or as a backup in flight, and another 120,000 kilovolts alternate current. We have also the batteries, 28 volts direct current, 48 ampere hours. And also we have the hydraulic system, the left and the right engine hydraulic pumps, the air pressurized, the C1 and C2. Also we have the electrically pressurized pumps for the hydraulic fluid that is being used for moving the flight controls like the horizontal stabilizer, the rudder, and also the other ones in the spoilers. I'm going to show you with the flight controls section. We have also other systems like the ADIRU, the Air Data Inertia Reference Unit. We have the flight control computers. We have also the we have the electronic engine control for the engine and the auto start. We have also the fuel management system, the left and the right wing and the center tank. So we have the forward and the aft fuel booster pumps. We have the crossfeed fuel valves and the low and high pressure fuel valves for the left and right engine, and the cutout switch that controls the fuel flow to the engines. Also we have the wing and engine guys, the fuel jettison with the dump fuel in flight. We have the cabin pressurization of the aircraft, the left and the right engine bleeder, the pressurizer from the left and the right engine, and also from the APU. We need for cabin pressurization with engine ADIs, also hydraulic fluid pressurization, air conditioning and ventilation, and also the APU drive and admitted bleeder. We need from the smaller turbine in the tail of the aircraft in order to start the engines in a cold and dark aircraft when the engines are shut down. So thank you very much one more time for joining me in this video. I'm Thomas Hatsios, the British American pilot flying the Boeing 777-300 ER in tonight's flight. So I'm gonna start now. You can see here we have so we have all the systems we need. So we have about an hour left for this flight. You can see the aircraft, the outside view also. So we're gonna start with that. Hope you like the inside, the whereabouts of the aircraft, also the outside view. So we're gonna start with the primary flight display. You can see the airspeed selected from the autopilot and flight director system panel over here. So we have the airspeed tape, the minimum airspeed displayed is 30 knots. The actual is 0 because the ground speed is 0, so the aircraft is not moving. We have also the radio altitude above the ground level. The magnetic heading and track, the magnetic north pole and north pole, the magnetic variation. We have the barometric pressure altitude, the barometric pressure of the outside atmosphere, and the barometric altitude displayed 1430 feet above the sea level. So we have the altitude selected from the autopilot and flight director system panel. The pitch ladder in degrees, you can see 2.5 degrees, 5, 7.5, 10, plus or minus 12.5, 15, 17.5, 20. We have plus and minus 20, and the bank angle also. And here we have also the rate of climb and descent of the aircraft, this state. You can see how fast the aircraft climbs or descends. So we have a climb, the needle moves up above the altitude window, or if we have a descent, it moves below the altitude window. So we have also the flight director with the angle of attack of the aircraft, the flight mode annunciator with the autopilot and the autothrottle and vertical navigation modes. We have the navigation display that displays, you can see the airports, the waypoints, other aircraft flying around you, the distance rings, the terrain and weather reflections. We have the settings for this over here in the weather radar, terrain and weather, and also other aircraft in the transponder. So you will see later the transponder, how we set up. Also we have you can see here we have the Switzerland, this mountain, here is France and here is Germany, all this area. So we're gonna be overflying a little bit of all of them. So Germany is mainly here, so pretty much here. So you can see the up, you can see the terrain level 6100, maximum 0 feet, minimum with red and green, and also the yellow is the intermediate. So we have an aircraft in a while. We can select also meters and inches of mercury or hectopascals for the barometric pressure. So now we have also meters, 10,000 feet or 3,050 meters, and 436 meters, 1,430 feet, 1,013 hectopascals also. So we're gonna set here, we have the autopilot over here, engage and disengage, the auto throttle left over here off. You can see the auto throttle left is off. We're gonna have the auto throttle right off. You're gonna see it displayed. You can have both off, so it will display here in the as a warning with the yellow letters. So we have both off. The flight director also, the flight level change. The flight director off disengages this. So we can have both flight directors either side. So this is depressible also, the autopilot on and off. Like this, you press out this switch. So you need also to cancel the warning here. So we have the autopilot disconnect like this. We also can re-engage the autopilot like this and cancel the autopilot from here using this small switch in the control wheel. So we press one time to disengage the autopilot, you will see the warning over here and here that the autopilot is disconnect, the red letters, and we have one more time to confirm the disconnect action like this. So the autopilot will display here if it is on. Also we can set the altitude in indicated airspeed from Mach, flight level change, auto throttle, and select an airspeed for takeoff. I'm gonna use this like 253, heading or track, the bank angle here, the limiter. So we're gonna select this heading. Altitude, disconnect. I'm gonna use this. So we have the flight director, flight level change speed. For this target, airspeed 253 knots, and this target altitude 25,300 feet or 7,710 meters. You can see 1030 hectopascals. We can also use the true or magnetic north pole. We have now the geographic north pole over here, the true north reference. So you will see RNP over here, true or geographic north pole here, and here is true. Also now we use the magnetic, the normal. You will see magnetic over here, and over here the magnetic north pole orientation. It is different depending on where we are in the world. Also we have, I'm gonna set back to inches if you fly in the United States or in Europe. So we have the warning that another aircraft has landed. So there's another one coming in. You can spot it here. It is coming. So we have the airspeed, the heading, the altitude. The only thing we left is the VS, vertical rate of climb descent. So we can use a minus the slider down for a descent, like minus 3,500 feet per minute. Over here you will see a descent rate here, a negative descent rate, minus 3,500 here. With this purple in the vertical speed indicator. So you can see here this middle down here, and also we can change into a positive. So from minus you will see the positive climb like this, plus 3,500. So now we have the plus. You will see VS again, and the plus sign over here in the vertical rate of climb descent of the aircraft. So you have to follow this for climb or descent. Also we can use the autopilot again on. We can use the flat path angle like this. So you will see a minus sign which signal descent of minus 3.5 degrees here for this from this altitude. If you like it, if we are cruising. So we'll start descending. You will see the purple arrow here, the stick mark. below the horizon line that signals descent below the horizon. So now we can see the autopilot also is engaged. This mode 25,300 target altitude to this target airspeed by path angle heading hold. Now we're gonna make it a plus a climb. So we're gonna have to move the slider the other way for a plus a climb like this. So you will see the aircraft climbing like this. You will see between the 3.5 and the 5. So you will see it later. So now we have the positive climb displayed in the primary flight display. And we have about 48 more minutes for this video to end. So I'm gonna show you a couple more things. So we have the flight level change with the autopilot on, with the heading. So we have flight level change, target airspeed and target altitude. So it's gonna give this rate path, this climb automatically. It's gonna be calculated from the flight director as climb pretty much 3.5 degrees. When we create a flight plan also, that is gonna be a little bit different. And also we need the hold the altitude. Either mode is overlapping each other. So now we have the altitude with the heading hold the autopilot on. So a couple more things to note. The thrust levers. I'm gonna talk to you a little bit about the thrust levers, how you can adjust the thrust, how you can disengage also the autopilot again like this. You will see the warning, the autopilot is disengaged. So we have the red letter right here, and we can reset like this and cancel the warning. So we have a couple of things here. I'm gonna show you later the flight controls, how you control the elevator, the rudder pedals and the ailerons and the spoilers in flight. Also the pitch string, the horizontal pitch string stabilizer. You can use this switch over here to press up and press down, pitch up and pitch down. So you will see the pitch string, the horizontal trim of tail of the aircraft, nose down or nose up here, how many degrees. Now it's positive plus 4 degrees, so it's gonna make the aircraft have a positive climb rate. The parking brakes here, for instance, the rudder trim over here, and the aileron trim, so the aileron trim has been displayed here. So the pitch trim of the horizontal tail. The horizontal tail is this section of the aircraft here outside. You can see the horizontal, the vertical tail, the rudder trim, and the aileron trim is here. You can see the ailerons moving. So this is the horizontal trim stabilizer, and this is the rudder stabilizer over here. You can use also the rudder pedals for moving the rudder, and the control column for moving up and down the elevator for climb and descent. Also the ailerons and the spoilers for bang rolls. Like this, you can see the bang rolls and the elevator. So we move the thrust levers. So we have the flaps. The flaps extend in the wings. They increase the surface area. The lift, they increase or decrease it, and the airspeed the aircraft can fly. So you will see extend and retract here. The speed brakes, you can use the speed brakes, extend them when the thrust levers are idle. You can extend the speed brakes like this. when you move the thrust levers forward, the speed brake retracts automatically. So you can see the flaps here, also the speed brakes, and they are extended like this. So we have the horizontal trim stabilizer. I'm gonna talk to you now. The horizontal trim position like this, up and down, and you have the horizontal trim. You can use the normal and the alternate tab for the pitch trim also. And also we have the auto trim system from the autopilot here, and the auto throttle. So we have a malfunction of the C1 and C2 hydraulic systems over here. Hydraulic pumps pressure is low, so there's no auto trim. We have to disconnect this the CNBR from the normal to cutout position. So you can see from normal to cutout like this. So we're gonna have only the manual over here, pitch trim, for the horizontal tail here of the aircraft. We're gonna have the manual pitch trim order. So we close this, we don't need that right now. So we have the left and the right engine, the thrust levers, the takeoff ground, the thrust reverse, the left and the right engine, the fuel cutout switch, the left and the right engine, the fire extinguishers. You can press and discharge. So we have also other systems I will show you later. So the auto throttle, when it engages, you engage the autopilot and the auto thrust, and the flight director commands over here. So this is the takeoff ground disconnect. Is the auto throttle disconnect switch over here. You disconnect the automatic thrust and you take manual command over there. So you have also the thrust reverse. If the speed brake is retracted and you move the thrust levers back to idle and you move up the thrust reverse, also the speed brakes extends automatically. So you will see the reverse here, both left and right engine. It opens the blocker doors, and the thrust reverses over here to slow down the aircraft after landing or in our ejected takeoff. As you can see, it deploys, so you can see the thrust reverse. Also you can disengage. You can see the blocker doors are open or closed. Now they're open. Also you can see again we can close them, disarm the thrust reverse, and extend again the thrust reverses. Don't do that in flight, only when landing or rejected takeoff before the Z1 usually. So we go back here. Disarm the thrust reverse. So I will show you also the thrust levers. You can move them both together or you can move one at a time. So we have a symmetric thrust, asymmetrical thrust like this. So you will see one thrust lever is above the right over here, 46.5. The other one, the left, is at idle, 22%. So now we move both together. Now we're gonna move the other side, the left one. So you're gonna see the left, the asymmetric thrust like this. Now we have 55% the left and 31.8 in the right. So we have the asymmetric thrust like this. So it's a good thing to move them together like this. You can also see the degrees of the flap settings over here. The flaps which are not related to the engines, and also you can see here the Boeing 777. You can see other things. We have the landing gear extend and retract. You will see the landing gear here, extend and retract, the alternate landing gear, the lock override if the landing gear is locked, the terrain override, the retract for the landing gear, and the extend the limits of the airspeed of the aircraft, and also the auto brake, maximum auto, rejected auto, and the flap limit for extend and retract, how many knots. So you will see some more information than the engine over here in the upper ACAS and indication controller system display. So we have the N1, the left and the right engine. We have 104.6% maximum continuous thrust or takeoff go around. 22% is the idle. So the N1 is the low speed starter and SAF, the low pressure compressor and turbine of the turbofan turbojet engine. We have the General Electric 90 turbofan turbojet engine, the exhaust gas temperature left and right engine, the bleeder, the pressurizer from the left and the right engine, also used for cabin pressurization and wing and engine gas de-ice, and the outflow valves for the cabin pressurization. Some other warnings here, other systems. Also the total fuel on board, 102.3 thousand pounds or 46,000 kilograms, and the temperature of the fuel. So we have also here the N2, which is the high-speed starter, and SAF, the high-pressure compressor and turbine of the turbofan turbojet engine, the left and the right. You can see the left and the right outside. The fuel flow per engine per hour in 1,000 kilograms or 1,000 pounds, the oil pressure, the oil temperature, oil quantity, the vibration of the N2 stage of the engine in inches, the horizontal vibration. So we go now, we have about 18 more minutes for starting the engine. So as I told you, we have General Electric 90 G90 turbofan turbojet engine installed in our aircraft, one on the left and one on the right wing for symmetrical thrust and redundancy. So we have also the FADECs. The FADECs are the full authority electronic control computers, one installed per engine gearbox. They control and monitor all the engine functions, like the N1. The N1 is the low speed starter inside the low pressure compressor and turbine of the turbofan turbojet engine. The exhaust gas temperature per engine, the bleeder, the pressurizer from the 5th and the 9th stage of the engine blades fans. Also we have the N2, which is the high speed starter and SAF, the high pressure compressor and turbine of the turbofan turbojet engine. The fuel flow per engine per hour in thousands of kilograms or in thousands of pounds. The oil temperature, oil pressure, oil quantity, and the vibration of the N2 stage of the engine. So we have also we have the engine start, engine shutdown, engine failures, the fuel metering unit, the fuel flow below in the high pressure fuel valves and the shut-off valves, and also other things like if we have the pressure inside the engine. So we have an overpressure, they can open the outflow valves of the 5th and the 9th stage to a higher setting, so they can relieve the overpressure from inside the engine. Also we have an under pressure inside the engine. The FADECs can control the outflow valves into a lower setting, so they can increase the pressure inside the engine. Also we have other things like the fuel mixture, they can control that also. So as the aircraft climbs, if we are in the sea level and the aircraft climbs from the sea level up to 20, 30 or 40,000 feet above the sea level, the air pressure, the air density is becoming about half that of or lower of that of the sea level. Also the temperature is becoming freezing, like -20, -30 or -40 degrees or even lower. Also the oxygen level is even lower, it's half than that of the sea level. So also the aircraft airspeed is flying like 2 or 3 times the velocity is flying in the sea level. So we have an intake from the front fan of the turbofan with the engines for compression inside the turbines and the compressors, and also the fuel mixture is having a different request every second as we climb from sea level to cruise, or we descend from cruise to sea level, or we change the airspeed. So this is adjusted by the fatigue automatically every second instead of doing manually like in the turboprop aircraft. So we have also the engine thrust. So this is mainly what the fatigues are doing. One install per engine, dual channel redundancy, one channel takes, the other takes over per engine gearbox. So I'm gonna talk to you now about the flight theory of the aircraft, about the newtons per second in third law of kinematics of motion, about the military of fluids, about aeronautical and aerospace engineering, and talk to you also. Then I'm gonna show you the flight controls, how control the flight controls. So we have a few more minutes for that. So you can see here we have so here we have the wings of the aircraft. You can see the weight of the aircraft is being held by the aircraft wings as the aircraft is flying. We have the thrust from the engine, the left and the right engine, the forward thrust propulsion, these vectors. We have the lateral vector from wingtip to wingtip. We have the longitudinal vector from nose to tail, and also the vertical vector that turns versus the center of gravity of the aircraft. So we have the mean aerodynamic core position. About 25% of the Mach is the position where the maximum aerodynamic lift occurs in the wings. It's also the position where the center of pressure and also the center of gravity of the aircraft, of the airliner, is being calculated. Also is the position where the top side of the wings becomes the airflow detached, so it starts the stall of the aircraft. So the airflow becomes detached from the top surface of the wings as the aircraft fly. We have a stall. So we have also the moment arm. This times the distance from the center of gravity all the way back to the horizontal or vertical tail times the airflow of the air mass per second times the acceleration of the earth gravity so over the surface area of the flight controller. So we have the moment arm or the lever arm that we can use to pitch up and pitch down the aircraft. We have also you can see here is the bottom surface of the wings. So the bottom surface of the wings, you can see the surface is more flat, so the airflow of the air mass as the aircraft accelerates for flight is moving slower. Using the Bernoulli theory of fluid, we have higher air pressure below the wings, which pressurizes the aircraft and the weight up into the air. Also, the top surface of the wings, it has higher curvature, the airflow of the air mass using the Bernoulli theory. Also, the Newton's physics is moving faster above the wings, so we have lower air pressure and air suction above the wings, which sucks the aircraft up into the air. So we use Newton's and Bernoulli theory also. So now we have about 12 more minutes. I have to talk to you now to show you about the flight controls of the aircraft. I will talk to you and show you the flight controls of the Boeing 777-300ER, how I control them using the side stick in this simulation. So I'm using Logitech Extreme 3D. So you can see here we have this side stick. I can pitch up and pitch down. As you can see, so we can pitch up and pitch down. The horizontal tail, also bang roll left and bang roll right. Also the rudder pedals. So you can see both are interconnected, both left and right side. Also I'm gonna show you now the outside. So you can see also the outside view of the same flight controls over here. You can climb, you can descend, also bungle. I'll extend the spoiler so you'll see better. Bungle left and bungle right. So the rudder pedals also the horizontal trim stabilizer, and we have the thrust levers here for the engine. So we control the thrust levers position like this by moving the thrust levers up and down using this slider. And with flight, so you can see the side stick deflection is proportional to the flight controls. Deflection, also the rudder pedals. So now I'm gonna show you the overhead panel and make an engine start demonstration. We have also the pit stream, I forgot to mention, the horizontal trims stabilizer for the horizontal tail. So we're going now in the other systems, and we're gonna make the engine start demonstration. We have 9 minutes. So you can see the overhead upper panel. This is for disconnecting hydraulic fluid for maintenance. In-flight distributed breakers. We have a more general view of the cockpit here. Also the controls. So I will show you now. We're gonna start the APU here. APU start. Start. We have the left and the right engine. The IDT. The primary flight control computers over here. This is the flight control computers, the ADU, the air dynamics reference unit, the electrical, the battery, the APU generator. So we have also the passenger oxygen, the window heat, the rammer turbine, the hydraulic. Over here we can turn off all the hydraulic. You'll see what happens. We're gonna have a reset of the hydraulics, and you will see now we have the warning here, the fault that all the hydraulic is lost. We're gonna have autopilot disconnect, the stabilizer, flaps controls, hydraulic, alternate flaps here you can see, primary flight control, and the hydraulic pressure Lszh and R. So you can see how well simulated the systems are. So we turn on the hydraulics again. All the hydraulic pumps, the primary and the demand, and the electric. So we're gonna have the warnings off one by one. So we have the electric, the hydraulic, also we have the electronic engine control here for the engines, the UC, the cargo fire, and also the auto start. Over here we're gonna use later in the on position. We have the normal and the alternate mode for the electronic engine control for the engines. We have the fuel jettison. We get down release hydraulic pumps in the auto. So you can see also we have the lighting of the aircraft and the windshield wipers left and right. We can dump some fuel in flight if we want to make the aircraft lighter for an emergency landing. The left and the right wing fuel tank, the center tank also, which is empty right now, and the pumps, the forward and the aft. The wing and engine got the ice over here. The cabin pressurization, auto or manual. We use the outflow valves as we climb or descend to increase or decrease the pressure inside the aircraft and select the landing altitude. Also we have the left and the right wing, the pressurizer. We're gonna see what happens if we turn off everything off. So this is what we need for hydraulic fluid pressurization, also for air conditioning, ventilation, wing and engine on the ice. So we're gonna have this warning, bleed isolation, no bleed, no pressurizer, hydraulic pressure demand C1 and C2 over here. So we turn on all the hydraulics and all the air pressurization we need also for starting the engine, the pressurizer. So this is all for the overhead panel. We're going now over here. So this is we have a few more minutes. Display is on. Engine status, you can see the APU is running, the hydraulic and the oxygen level. The checklist over here. We have the checklist, normal menu. If we have a failure, what we need to do, no time now to show everything. The communication, notice the doors are closed, the cabin of the aircraft can be pressurized. The landing gear, you can see the pressure of the tires and the temperature of the brakes. The electrical system, left engine, right engine. Also the APU generators on, the battery voltage over here, and the charge or discharge of the batteries. So you can see the drive is on, also the backup generator. So we have also the hydraulic left and right engine, where the hydraulic fluid goes. 3000 psi, it's left and right engine, and the air pressurized, the electric, and also the demand, the shuttle valve. The fuel left and right wing, total fuel on board, how much fuel in the left and the right wing, also the left and right engine, the fuel flow below the high fuel pressure. The center tank is empty with the yellow crosses, you see 0. Also the APU is fed from the left wing using the DC motor. You can see also the minimum fuel temperature below which the fuel freezes. So we have the air, the pressure from the left and the right engine and the APU. If we increase the thrust levers, you will see more pressure coming in from flight controls. Also, you can see how you use the flight control stabilizer position. So you have this view here. You can see also the other side, the rudder pedals. So this is all working normally. There is no failure. Also, the stabilizer, how much degrees we have in the stabilizer. So we'll go back into the engine and very fast the engine start like this. Turn off both engines. So we have the reset in the overhead panel. Both engines are down. Engine auto start left and engine auto start right. Engine shut down. You can see the engine, the rate is slowing down, and 2, the fuel flow is 0 right now. So if you come outside, you will see both turbines, the right and the left wing, are only having pressurized air from the APU. So we can admit the fuel for both left and right back on. You will see the fuel flow here below the N2 will increase from 0, and we're gonna have both the right and the left wing. You can see the spinners of the turbines, and the engines are on, are ready for takeoff. So we have only one last thing left. We have the electric back menu, FMC, the position. You can see the model Boeing 777, how to calculate Lszh, the inertial reference position, departure 0 fuel weight, gross weight, the reserve fuel for this flight, and the cruising altitude 25,300 feet. Over here, the cost index 100%, minimum fuel temperature, center of gravity for flight, and also departure and arrival, airport and runway we're gonna use for takeoff. So this is the flight management computer, the FMC of the aircraft. Select the departures for this airport, trans, the fixes, the waypoints, and the arrival. So we're gonna have a complete route of flight plan. This is the flight plan of the aircraft. So we cancel the discontinue to activate and execute. We have only one last step before takeoff. 15 degrees of flaps, 26 degrees the horizontal trim, stabilizer, and the center of gravity of the aircraft for this runway and this takeoff weight. And we have the V speeds, the takeoff speeds. So we have only 18 minutes left for this flight. We can just start the taxi to the takeoff process. So we take the runway clearance and we depart. We use also the tiller here for steering and the rudder pedals for making a right turn. So we have enough thrust. So the runway is empty. There is another aircraft. Also you can see the navigation display, and we take takeoff clearance from air traffic control. Now we steer to the right like this, using also the rudder, right rudder. We align in the center line. And the Lszh parking brakes again. So we're gonna use this. For this display you will see a different terrain scan radar. Also you can see the airspeeds, everything is set, the LNAV, the flaps, and the horizontal trim here, the stabilizer before takeoff. So we advance the thrust levers for takeoff. We have the warning because we have the parking brakes on. So this is the outside view where we are and where we're going now. So we have a better view like this for takeoff. Cancel the parking brakes and go full takeoff, go out. So we use the flaps up for takeoff, 15 degrees. So we have V1, we rotate, here we go. And this is the positive rate of climb for the aircraft. So we retract the landing gear up, and you can see some data about the flight, the pitch stream a little bit. So we are 1,500 feet above the ground level, the airspeed is 200 knots. You can see we are 2,200, 300 feet above the ground, but 4,000 feet above the sea level. You can see the airspeed and the stall speed and the pitch altitude of the aircraft is about 80 degrees, and we keep climbing with 6,000 feet per minute. You can see the terrain scan and other information. We have the stall speed also here, the warning 140 plus knots, and we need to avoid that to stall the aircraft. So this is the takeoff. Now we need to start steering around, and we have about 15 minutes left for this video plan. Keep climbing. So you can see the positive climbs here. So we pitch stream a little bit more. Use this pitch stream here. Now I'm gonna show you also the outside view where we are. So we depart Zurich, and we're gonna come back for landing. We're gonna make turn, and you can see the aircraft, the Boeing 777-300ER. Hope you like this view. We have to make up there now. And we have more 14 minutes left for this flight. So we keep climbing. We need to align. So you can see the France here and the Germany in front of us. This is Germany in Bayern Munich and this is Switzerland here. So we keep climbing. We're gonna need to transverse the first waypoint over here. So we cross 17,800 climbing. So you have the France, 17,000 feet. How better view now. 2227. So we can fly with about 600 kilometers an hour. So we're gonna be overflying the lake here, the Germany in front of us, and the France. And this is also the galaxy and the stars. So we're gonna have the chemtrails a couple of seconds. Keep climbing, and we have 2 more minutes. So you can see we have the Bayern Munich in front of us, the Germany. This is the France. You can see. It's the autopilot here set. So we keep climbing. You can see the stall warning, and this is Mach 0.534. Let's do it again. And we have about 11 more minutes for this video to end. So we crossed 33,000 feet. Keep climbing. 34,000. We're gonna have the mode. You can see the target altitude, the target airspeed. We're gonna start retracting maybe the flaps up. So here we have the cruise altitude. We reach cruise altitude now. So we're gonna level off for a while. You can hold level, and this is we have the chemtrails behind us and the galaxy, and we have about 10 more minutes left for this flight. So we have the Germany in front of us. You can see the Bayern Munich, this area, the France, and the Switzerland behind us. So we are also, we have the lake, this beautiful lake. So this is our spacecraft for tonight, the Boeing 777-300ER. We have the star sign in the galaxy. So we're going back now to the airport. We need to start the turn. We advance the flaps up. And increase the airspeed, and also trim down the horizontal trim stabilizer. So this is how we turn. We need to level off a bit here. So this is the turn over here where we are. You can see the chemtrails, the frozen vapors. So now we fly with 900 kilometers an hour, 300 meters per second, 35,300 feet above Switzerland. Above we cross the Germany, the Bayern Munich behind us in the front, and we're going back to Zurich. So we have the Swiss Alps, and this is our spacecraft, so also the lake. Beautiful views. So I hope you like my Boeing 777-300 of the PMDZ simulation and Microsoft Flight Simulator X. So now we need just have a few more minutes to go. Also maybe connect the autopilot like this, just for display. So now we're gonna have the autopilot on for steering back into the airport. You can see all the data here. As you can see, the autopilot on, and we fly now with the autopilot connected. So this is our spacecraft for tonight, Boeing 777-300ER. We have the chemtrails, 35,500 feet right now, and this beautiful star sign. So we need to steer back into the airport. I'm gonna use this and start descent direct to. And start a descent. Also the airspeed decrease. Also the speed brakes. So this is it, we descend back to landing. Also select the approach speed, the approach and landing speed, the legs here, 32,800, and also the rate of descent. So we're gonna descend using also the speed brakes and a higher descent path like this, and we have 5 minutes more. So we are much closer now to the runway. You can see the runway here, the airport. You can also decrease your speed even further. You can also deactivate the autopilot like this. So we have 4 more minutes. I'll use some flaps maybe. So we have manual control of the aircraft right now, as you can see. And we have 3 more minutes for the video to end. We hold here the altitude. We have the word localizer on. So we have So we have 2 more minutes. We use idle flaps now. So you can see we have manual control of the aircraft. I'm gonna use idle flaps. Hold level for the flare 100, 50, 30, 10. We would just touch down, as you can see. Parking brakes and reverse. Full reverse flap. So we touched down and we are having a beautiful landing. So we have a few more seconds. So you can see here the nose works perfectly well and safe. Also there's no breakage of the tires or the strut. The landing gear over here. Also the left and right landing gear, you can see all the tires are normal. There's no breakage of the wheels, unlike some other pilots are doing. So you can see the aircraft is